Hello and welcome to this week's episode of Automated, being filmed via voice technology, which is a new innovation from our global world headquarters in San Francisco's Mission District. This is the second time that we're doing an episode of this where we're forcing the entire team to listen to the podcast because that's the only way we can get them to participate in it at all. I, of course, am your host, Stefan Ilia, CEO and co-founder here at Polymath Robotics. And across from me is a Quebecois drinking man with a shirt that says he is a total Ross bag. And I'm not entirely sure what that reference means. Sir, what is a Ross bag?
Well, depending what you're talking about, it's either a unit of measure of data. Mm-hmm. Not even measure, it's a storage mechanism. Or it's a measure of my own self-worth.
Which has many terabytes.
Yeah. Or the opposite, you know. As somebody who lived in Quebec,
kilobytes or terabytes, depending on the day.
Lived in Quebec for 8 months in the fun part of Montreal. I gotta say the combination of Quebecois beer and Ross bag is speaking to me right now.
It's speaking to you?
Yeah.
Well, I mean, it's a good place to work on robots. I've recently, I think I went like 32 years without ever visiting Canada, and I've been now like 3 times in the last 12 months. Something about you Maple Leaf people is dragging me up there.
I promise has nothing to do with your co-founder being Canadian.
Or the fact that Canada, with a rich economy and a dearth of blue-collar labor, is one of the best automation markets in the world besides, Australia.
Yeah.
But that's a topic for a different day. This, of course, is Automated, where we talk about robots. We do 2 parts of this podcast. The first, we start off with a game where we spitball a robot into existence. And the second, where we talk about some sort of topic in robotics. And Ilia, what type of topic are we talking about today?
We're going to talk about small robots and how they feel like they should be much easier than big robots.
Yeah, it's not that big of a deal. It's just a little robot with a couple of sensors on it.
Small stuff, but generally tend to be harder to actually make anything useful with.
Yeah, well, we'll see how it goes. All right. So now playing our game, sound effects.
Note to editor, leave that in.
As well as that note.
Yep. All right. For our business use case today, I'm shuffling my paper here. We are going to have... No, we did that one already. I'm terrible at shuffling. I'm sorry. I just don't want to bore our listeners here.
A bad shuffler.
Jeez.
You would never make it
Port.
in a Las Vegas casino. A port.
All right. Now, we can be creative. We can interpret that as a place for ship's dock or a type of dessert wine. We'll see what you pick.
Actually, we're going to get too close to real work if I pick that one.
This is a purely random draw process, listeners. There's no selection bias whatsoever in our choice of topics.
All right,
Stefan has now rejected 6 of them.
Make that 7.
7. All right.
Oh, how about this? Too close to real.
Oh,
the
my
problem
God,
is,
man.
The problem is I know a lot about what people are doing in ports. So I keep on running across things like GPT-3 in ports, which is a whole thing.
But I don't. So that's the fun part.
Yeah, I guess. How about quadcopters in ports?
Quadcopters and ports.
Yep.
Okay.
Ports are an interesting market. They're actually incredibly undifferentiated from each other. So it's a surprisingly commoditized space. Whether you get your goods into America through the Port of Seattle or Oakland really doesn't matter for like your shipping time. So if it's like 50% cheaper to land in Seattle, you just land in Seattle. So on one hand, magic robots making everything cheaper could be good. On the other hand, there's not really a lot of fluff for like building a premium port experience. Like that doesn't like with quadcopters, for example. Anheuser-Busch once did a very, very spoofy business promotion where they had a bunch of drones like deliver beer to people at a music festival. That happened like once. That was like a one-off, and like doing that in a port, not so much.
Well, you've heard the news of what Hyperloop has morphed into. So a bunch of the groups that were trying to do Hyperloops decided eventually that probably not very safe to sling around people at these speeds. But what you should really do is cargo. So the real problem facing logistics is not the 3 weeks it takes to take a boat across the Atlantic or the Pacific. It is the 4 days it takes to get from the port to the actual destination warehouse.
Yeah.
And they want to cut that down from 4 days to
4 minutes.
2 days.
I was talking to somebody the other day about spin launch, which is basically a rotary space catapult. And a problem that I never thought about with it is, it accelerates at up to 20 Gs. And I'm pretty tough. So I could totally fly a fighter jet at like 5 Gs, because that's just me. I'm built like a fighter pilot, but like, you know, avionics don't do very well at 20 Gs, let alone in case the thing ever like bumps into the side.
Speaking of 5Gs, you and I read the same Reddit post of somebody being like, look, here's proof of health problems due to 5G. And they linked a study about the health impacts of being accelerated.
For those of you who don't remember
5Gs.
physics, a G is also a unit of Earth's gravity. 1 G is 1 Earth gravity of force. So with that being said, what are we doing with quadcopters and ports? I know a lot of people have tried to do quad security copters. However, a thing that I think, here we go. So whenever you ship things, there's a lot of pieces of paper. And it's really hard to digitize things. It's, you know, we're talking about like one of these massive markets with so many different parties that you can't really combine into one. There's going to be paper attached to every shipping container. There's going to be paper that every truck driver who comes in to do a drayage haul has to interact with. And like, you know, we can't really rely on them having a good like camera on their phone to digitize these pieces of paper. So we have a quadcopter that flies around with a paper scanner and flies up anywhere that paper exists. And you like feed the paper in, you know, sheet at a time, and it scans the paper for you.
Wait, so as a person who's not been around a lot of ports, are these papers stuck to the side of these containers that are stacked 12 high?
Yeah.
Okay, so that, like, you know, there isn't actually another feasible way to see this stuff.
No, but like basically you can think about it like a plastic sheet, like taped or stapled or whatever to the side of the shipping container. Then you have to open up that plastic sheet, and there's like 8 pages or 25 pages of documents, custom paperwork, bill of lading,
customs paperwork,
like what's in it, like all of that, all that crap.
So what you want to do as a port is not wait until that's offloaded and at ground level where a human can do it. You want to actually take that paper when it's 20 feet up in the air. Yeah.
I mean, that would save you time grabbing it down. But more than that, you could basically, like the scanning robot could be a universal like API to get things from paper into digitized form.
So you know, we have to develop all this software to automatically track pieces of paper. So anybody wandering around the piece of paper is just going to get a swarm of robots following them around, trying to get a clear shot of this.
Take out a dollar bill to buy a bag of chips.
Yeah, and it's just like
zabs it from you, and then like spray paints a barcode on you that has the same information as, you know, $1.
Yeah. Or even better, you know, if they have to open these little plastic containers, these robots, you could try to do like little saws or whatever, but no, lasers. So these are laser armed drones that will fly around trying to laser the outlines of any roughly rectangular piece of roughly paper looking thing.
Let alone like if you have something that looks like a white square on your shirt.
Exactly.
Boom, just cuts that shirt
right off you.
So in terms of how this works, they probably need to be constantly like patrolling and seeking out their prey,
because ports are famous for being constantly in flux.
Well, there's a lot of stuff going on in a port, and like a lot of these containers will go into a lot of different places. And this is more about like removing the bottleneck of somebody ripping off that customs paperwork and reading it, and basically letting that happen anywhere. Just like get the containers off and figure out what they are afterwards. So like you constantly patrol to find new pieces of paper to scan. And then either you get summoned by a person who's already unsheathed them, or you unsheath it yourself by burning it off the side.
Yes, exactly. You laser it off the thing. Okay. I mean, your average quad rotor has a runtime of 20 to 40 minutes, let's say.
And that's like a pretty hard physics limit too. Like before we talk about adding a paper scanner, before we talk about adding a laser to open it up, like it might be that the laser burns out 3/4 of the flight time. So fly over, laser, 3/4 of it, fly back.
It's a chemical laser. It's a chemical. All the cool kids do chemical lasers these days.
Okay, I was never invited to those after school parties.
Yeah, it's a chemical induced charge pump laser. So it takes one shot, and then it has to go and eject the spent cartridge and reload. To take another shot.
Good.
Excellent.
Good. The port's gonna be littered with spent cartridges.
Yes,
like ports already are.
Of horrendously not pleasant chemicals used in charge pump.
Whatever.
lasers.
If they fall into the water, no big deal. The ocean's big. It will deal with it. So lasers, that's not a big power draw. How do you actually think about mission planning for the patrolling?
Well, I mean, I would assume, again, not being a port person, that these containers aren't just scattered everywhere. They're sort of in somewhat rows.
I mean, I think that's a strong assumption.
Well,
like
okay,
they're in
like,
rows, but like the rows are not all that organized.
Yeah, sure, but they're not like randomly strewed at a 45-degree angle.
Yes, that's
vertically,
true.
right? Like they're
That's
not on
true.
their side.
Yes.
Right. So you can assume verticality to some
Yep.
level. You can assume somewhat neat rows.
Yep.
Right. Plus or minus 10 feet, let's say, or 5 feet. So you'd want local obstacle avoidance, but you could, you know, if you fly above the height of the containers, get pretty decent GPS,
Yep.
fairly good accuracy GPS. Localize where you are, fly down using pretty basic
Yep.
stereo or ultrasound to not hit the thing as you're trying to navigate around it. Then just go into optical search mode, right?
Mhm.
Just try to localize, center yourself on the paper, on this 2D plane.
Well, like not everything, some things will already be in the ERP system.
Yeah.
So like some things, you know, there's a number on the side of the container. They've pre-sent stuff that's been that's been identified. You know what that is.
Oh, now you're really getting into a real use case, because
yeah.
there are companies that build cameras that you strap to the roof of
Yep.
Yard trucks.
Yep.
That just constantly scan these numbers
Yep.
on containers.
But that's not a
maintain-
quadcopter. And quadcopters are cool.
Very cool, especially laser arm quadcopters. Yeah, absolutely. So constantly driving around with a bunch of cameras facing in every
so
direction.
we're looking for we first, like, we probably follow preset routes.
Yep.
Or maybe randomized routes to find outliers more easily. Find ones that don't have an associated with number.
Yeah.
And then we have to trigger our laser. Once we trigger the laser, we also have to catch the pieces of paper and feed them into the paper scanner.
No. You scan it just with a high resolution camera on the drone.
No, there's multiple pieces of paper stacked on top of each other.
No, I understand. Sorry. Let me back up. You laser the plastic off.
Yep.
Then you somehow pick up the stack of papers. Doesn't matter how, right? So we'll come back to it.
Dexterous robotics, no big deal.
No. Vacuum pick in place.
Okay.
Right, like a big suction cup and a little pump. We'll do that. You fly over to some level surface. You drop it again. You laser off the corner that's stapled,
Mhm.
and then you just take photos of it and you move one page at a time. Very simple.
Okay, so you're not thinking like one of those like feed them one at a time.
No, because that'd be
Scanner.
so much harder. That'd be so much
But
harder.
yeah, but you're not really gonna have a flat surface that's controllable.
No, I just realized a bigger problem with my own solution. As soon as you put it down, your downdraft of your own quadrilateral
blows it away.
Blow the paper away.
Yeah. I mean, wouldn't it like? So I think you could assume a certain level of cheapness and translucency through the paper that they use in this. Wouldn't it be easier to just laser the plastic thing off in a clever way and then scan all 5 to 50 sheets at once with some magic industrial scanner that can see through paper?
I mean, there's techniques like that are being used to recover ancient scrolls and things like that have been burned.
Yeah, let's bring archaeology tech to ports.
Exactly. But those are like,
that's a common pitch.
Yeah, X-ray tomography kind of stuff, which is big, expensive machinery and a lot of compute power. I mean, ultimately, you can see anything if you put a lot of light to it. So if we already have a chemical laser source, we might as well use a chemical light source and just put out 50,000 watts of just light, which will give enough photons through every sheet of paper to bounce off the ink and get back to it. But this would be like the brightest object in the sky every time it goes off to scan 20 pages deep.
Okay.
Like 3 pages, you might not have to go that excessive.
Yeah.
But 20 pages, the amount of photons to hit every page.
Especially 20 pages that have been crumbled together and of unknown origin for months.
Yeah, exactly. Like scanning through stuff just requires so much light.
Yeah. Okay. So can't scan through stuff. We can't place it down.
I mean, you can. You'd get police reports of flash bulbs going off at all hours of the night and day.
I mean, what you could just do is you could just take the paper to a central place to read them, which begs the question of why are you doing this in the first place? Why do you even need this
efficiency?
Yeah.
So the reason is you have 2 laser cartridges on the quadrotor. One to free the paper, the other one to threaten the person who's supposed to scan the paper on the other end to work faster and scan the paper.
I'm sure the stevedores union would love that.
Absolutely, yeah. I mean,
alternatively,
use their
if
members?
if you just remove this entire problem set and said, all right, this only works for people who have uploaded their bills of lading into some central database beforehand. What you could do is you could fly around the incoming ship and locate at where every important container is on the whole boat. But that does sound way too close to an interesting real business.
Yeah,
so I think we need to go back to shooting lasers at things.
Shooting lasers. I think the real benefit of this is your quad rotors double as security devices.
Mm-hmm.
So anybody tries to enter a port, you just laser them.
Or you fix their eyesight.
But I mean, I guess no eyesight is a fixed type of eyesight.
Yeah, lasers, laser eye surgery, it's all the same.
Close enough. But yeah, I mean, the main thing I think would be to catch contraband and that sort of stuff. But I don't know how this would help with that so much.
I mean, if the drug smugglers filled out their paperwork and like said declarations, I am smuggling drugs. How much? 25,000 kilos.
Well, yeah, quick sidebar. We got to wrap this up. But quick sidebar. A really cool thing that a colleague of ours had worked on was scanning containers as they come in by using gamma rays from the universe. And basically, the scanner was just one set of tubes above the thing and one set of tubes below it. And as you put the container through, it would figure out the path that these gamma rays take through the material and figure out pockets of high and low density. So like using ambient gamma rays. And
I think the problem with that project, if I recall correctly, was that scanning each container was like an hour.
Yeah, exactly. Yeah, because you're waiting for the universe to provide you your high energy particles, right?
No big deal.
No big deal.
For those of you wondering, trains typically have about 7 miles worth of shipping containers on them. And a super freighter will often contain somewhere like 27-mile trains worth of shipping containers. So if each of those has to go through a 1 hour long gamma radiation, stop, you're never getting another iPhone. That's just out of the cards. Maybe you can get the iPhone 15 in like 2030. So I think a system like this, it's enterprise software. It's for a massive port, you probably need in the range of, assuming a third of your drones are down at any point in time, you probably need 50 to 200 drones per port.
Yeah.
You're probably looking at roughly a $4 million a year system. And maybe 40.
And the lasers are probably ITAR classified because they're military grade.
I mean, you can only have, but however, now to do anything in ports, you need to be a U.S. citizen because that keeps our safety.
That's right.
So that actually wouldn't be the biggest problem. That's one of the smaller problems of this. We've already basically made it really hard to, go unload a box of whitey tighties from a shipping container.
Keeps us safe.
Yeah, keeps us safe.
I mean, so this system, it's consists of quad rotors that fly in the sky.
Yep.
And they try to network your series of ports and containers.
Yep.
So I propose we call it Skynet. Because nothing bad could come from quad rotors that autonomously shoot
Skynet
lasers at
Port
stuff.
Edition.
Yep.
Yep.
All right. Coming to a port near you for the low cost of $10 million and whatever the DoD spends on laser efforts this year.
I was talking to a friend the other day, and they were talking about different robot projects they want to look at. And they're like, I don't want to do a big complicated thing like you guys are doing at Polymath. Polymath, we often do, big articulated dump trucks, really large tractors pulling tandem trailers in a field, massive bulldozers, whatever. I don't want to do something that's big and that's complicated. I want, just like simpler robots, a nice like small robot that I could sell to like the everyman who wants to do something in a particular use case, maybe a target price in the $1,000 to $4,000 range.
Yeah, I mean, I love it. I would love if we lived in this future.
I guess that the topic that I want to dig into today is, why are small robots so damn hard?
Yeah, I think it becomes kind of a problem with capitalism, which I'm a huge fan of. Let's start with how capitalism is one of the evils of the world. No, the problem
this is our business podcast.
Yeah, exactly. So the problem is that to do anything cheaply and still make money, you have to do it at scale.
Yeah. And
so that's the real problem.
And really, the cheaper you need it to be, the closer to cell phone scale you need to be at.
Yeah, you need to be.
So like, if you want to have a complicated computer that you sell for $1,000, you need to sell a couple 100,000 of them.
Yeah. Right. Exactly. So if you want to be able to afford rent in San Francisco,
yep,
as a human,
yep,
you either make something expensive and low volume or cheap and very, very high volume.
Yep.
Very, very high volume presents its own challenges. Like, assuming you had a magic robot built, right? You figured out the magic robot, it works perfectly. Getting 10,000 of something to somewhere is logistically complicated. It's expensive. For robots themselves, you need to do software updates like we talked on last podcast. So you need a whole infrastructure system that could handle 10,000 robots, that can handle training your assembly partner in China probably to actually flash these robots with the right firmware. So scale is your number one problem. But let's assume you put that aside.
Yeah.
Like, okay, so scale's not an issue.
Let's say you're Amazon. And
you're
you can
Amazon.
just cheat. You can just cheat scale.
And you're building the Astro.
Yeah, or maybe not the Astro, just like an Echo Show on wheels.
Sure.
That goes around my house and carries my cups for me.
Yeah. Another quick side note. Halfway through the Astro program, I think Jeff Bezos tweeted a photo of his kids had duct taped a Alexa on top of a Roomba. And our entire team was trying to kind of decrypt what he was trying to say with this. Like, is this a joke? Is this him saying that you guys should be done by now?
It's a statement about how efficient big companies are.
Yeah. They later bought iRobot, so maybe it was some sort of cryptic message. Who knows? But yeah, so okay, let's put production aside. The other problem starts to come into play, which is that robotics are at the cutting edge of what we can do with computers fundamentally. And so you're always starved for compute power, you're starved for energy, you're starved for resources like optics for your lenses and that sort of stuff, where everything gets harder the smaller and cheaper you go.
Yeah.
Right? If the Astro, for example, uses basically a tablet processor, which is powerful, but is nowhere near as powerful as the stuff we put into our robots.
Well, let's talk about some concrete examples that are a little bit closer to home than the Astro.
Sure.
Which, I would bet that besides you, no one listening to the podcast has ever gotten to play with in person.
Go check out the videos. It's a nice.
Yeah, it's a cool tool. It's a cool product.
We should get one for the office.
We should. I'd be all about that. However, let's talk about maybe a delivery bot. So I could see a VC saying about delivery bots, like, hey, it's just not that big of a deal. Like, you have your robo taxis, your cruises, your Waymos. They have $300,000 of sensor on it. Sure. Whatever. We're not doing something that important. We're not driving on the streets. We can't hit a person and kill them. It just isn't that big of a deal. Make me $1,000 delivery robot.
And in some sense, they're right. Like making $1,000 robot is still simpler than a fully autonomous vehicle, for sure. But it is not trivial.
I think the challenge is it's not simpler enough.
Yeah, that a small team can just tackle it with no problem.
The fallacy, even in what I just said, is a delivery bot can kill somebody.
Yes.
If you are the wrong age and one comes barreling you, or you're sensitive leg syndrome and one comes barreling and hits you and you fall down a flight of stairs.
Or even simpler, it just nudges into you at the wrong moment when you're standing at a crosswalk and just pushes you into traffic, right? That's you could be any age and that would happen, especially since they're quiet. That should be actually a good sci-fi plot for a murder mystery. Who hijacked this thing? Anyway, but yeah, so you're faced with many of the similar scale challenges to autonomous vehicles.
Yep, but with none of the money.
So you can't afford good sensors.
And also the money going away also means investment is harder to get. Yeah. So you have less resources to be able to buy less BOM, which means you can't buy it at any scale, which means you have even less resources because everything's more expensive.
Right. So your problem might be 10 times easier than full autonomous vehicles, but your team is 200 times smaller. It's a hard bargain.
And your relationship with suppliers is 1/1000th as important.
Yeah, exactly. And at the same time as your relationship is complex and difficult to actually build as a small company, the integration importance of sensors and compute on a small platform becomes exponentially more important.
We were asked to look at a drone thing recently, and I guess and a part of it was, why can't you do Polymath for drones?
Yeah. And my kind of pushback on this is that drones are hyper optimized because of batteries and weight. Yeah. That
what I think I said earlier about how a 20-minute flight time is more or less a physical limitation, is that as the vehicle gets bigger to have more battery, it weighs more, which means it costs more energy to stay in the air. And more or less, you're stuck at somewhere between 20 and 40 minutes of flight time. Whether it's a drone that weighs 10,000 pounds or like the weight of a piece of hair. It's only going to be able to fly with current physics and current battery technology for 20 to 40 minutes.
Yeah, and Stefan means specifically quad rotors.
Yeah.
There's people doing fixed wing drones that fly quite a lot further, but they're exactly, different physics. But yeah, so the quad rotor one is a good example where because of weight constraints, you have to be highly optimized for what you're trying to do. So your motor drivers have to be very small and efficient at the same time as they have to handle hundreds of amps of current.
Yep.
So you're pushed to the kind of the extremes of engineering.
Yep.
To get it to work.
Which is part of why I think it ended up being so winner take all.
Yeah.
Like as the Chinese companies like DJI like got market traction, they could make a even more integrated, even more optimized product, which allowed them to cut even more weight and be closer to 35 minutes of flight time or 28 minutes of flight time. Whereas people who were just kind of phoning it in were able to only have 20 minutes. And turns out that's a killer feature.
Yeah. And plus, their optics integration and all the machine learning stuff they use to track people, all these nice features are very difficult to do using disparate systems. And we speak from experience because we're doing sort of the similar thing but in large vehicles.
Yep.
And there our margins are a lot better. We can afford expensive sensors, we can afford big compute, we can afford to have the system stop and think about things if something jumped in front of it, for example. And so our problem on a large mining vehicle is in a lot of ways much easier than a sidewalk delivery robot.
Yeah.
For a much larger budget.
Yes. Which is, another thing that I think we've talked about on the show before is we've essentially found that the larger the vehicle, the easier to automate and the more valuable to automate it. Whereas like as you get smaller, as you get more cramped for space, everything just gets harder.
Yeah.
And you have less money to solve the problems.
Yeah, exactly. So you're kind of hit from both directions.
Yep.
The plus side is if you're working as a hobbyist or as a bootstrap startup, much cheaper to get small hardware. So if you're really,
you can build an AMR a lot cheaper than you can build a
mining vehicle.
Yeah.
Yeah, exactly. So if you're truly just starting out and you want to prove yourself, what did we start on? We started on a ClearPath Jackal because we had one lying around and it's cheap and I strapped some sensors to it and there you go, right? But as soon as you exceed that step, you got to go up market as quickly as you can to survive.
Speaking of like, how did like ClearPath's robots aren't that big? How did it overcome this?
ClearPath's market was different. ClearPath always targeted universities, research groups at companies, that sort of stuff, like early ClearPath before Auto Motors. And so they could afford to target very large margins for
small robots.
Not only small robots, but small robots that functionally didn't do anything. Like that, well, intentionally, right? Like they weren't trying to deliver food. They're trying to build a platform for other people to develop algorithms to deliver food.
Yeah.
They're selling shovels. They weren't mining gold.
So they weren't, for example, trying to build a delivery bot with a BOM of $2,000 so they can sell it for $8,000 and make $1,000 a month on top of that for us. They were selling a husk of a delivery bot for $15,000 and
Bingo.
saying, You can program
you guys figure it.
You figure it out.
Well, yeah, and that works if you're selling to research companies. That's exactly what they want. They want a shell that they can hammer at and work on. So it was very successful. And there's a few other companies, of course, that do similar things. But that's a different market than trying to provide an end useful robot. So I guess the caveat we should say is small robots that have a targeted application are much more difficult than kind of development platforms or toys or that sort of stuff.
But toys themselves.
I think toys,
I think another challenge with small robots is big robots you get out of the way for. Like when we look at the 400-ton mining trucks, if you're close enough with one of those to see whether or not there's a person in them or not, they're already unsafe and they should already be stopping. A little toy robot, like, it's really not allowed to trip grandma.
Yeah.
It's really not allowed to run over baby. And actually, like, again, like the standards, Ilia shakes his head. I guess is the Astro allowed to hit babies?
I know. I'm thinking something like even smaller than the Astro. I'm talking like a toy car, like an Anki racer. Yeah, Anki had no protections to hit people. Like it would hit people any day.
But the Anki racers were a secondary product. The initial one was like the Cosmo or something.
Yeah, I played with one of those. It was great. Had no protections to not hit people.
Oh, really?
It weighed like 20 grams. There's
really that light?
Yeah, it was tiny. It was the size of my palm.
Huh.
I don't know, 100 grams. Fine. Right?
I don't speak metric weights.
All right.
A pound?
3/10 of a gopher's left leg. I don't know how Americans measure weight.
Thank you. And now I perfectly understand that weight.
Of course, had to use fractions too for your American audience. But yeah, no, actually, I played with that one with my nephew for quite a bit. And and again, like that's a good example where the Cosmo did localization and mapping on a monocular camera with a processor from like 2008 low-end smartphone. Mind-blowing, right? Like 2 or 3 PhDs probably spent a year or 2 years tuning just that one feature. And it still worked okay.
Yeah, I mean, I've never found anyone to be like crazy impressed with the Ankis, even though I know how hard
it's
every
super
problem.
Hard. It's super hard.
And I think Anki as a company raised like $100 million to build this toy that like people were like, but this isn't a very smart robot.
Yeah. Like all of it was super fun. I was using their Python, I think, at the time interface to Cosmo, and I could see raw outputs of the cost maps they're generating. And they weren't even cost maps; they were octomaps, I think, that would self-divide to account for space to save memory on this thing. And still, like, it was nuts. I was impressed how well it worked. But as my nephew playing with him, he was like, "Yeah, okay." Like, it sort of doesn't bump into stuff. That looks cool.
It was a type of toy that's really cool if you explain
for
how
roboticists.
Cool it is.
Yeah, it's a great toy for roboticists.
Yeah,
but yeah, so it's just that all the way down.
So your point being that like small robots, if they need to do anything, it falls out of the art of what's possible.
Yeah, and I think the meta point is humans keep wanting us to be further along the robotization path than we actually are.
Yeah.
Like we keep imagining that we're at the Jetsons future.
And I think part of it is like everyone wants that so badly. They'll happily listen to lies that tell them it's true.
Are just not feasible, right? And so everybody wants Rosie from the Jetsons.
Yeah.
And we're like, we're not even close.
What's funny is the number of people have told me that phrase of everyone wants Rosie from the Jetsons. Sometimes saying that's what we're going to build is funny for that particular example.
Yeah, exactly. There's equal amount of people saying that's what we're targeting, and the other half the people saying that's a stupid thing to target. So I think fundamentally we're not there, and we're getting closer, and it's really hard to predict when you're going to get there. Like Anki, before they crashed, I would have thought like it seems like they're kind of there, right? Like it mostly doesn't hit stuff. It mostly navigates well. Their market fit was obviously off.
But you also, I mean, like the problem is you combine hard robotics problem plus the market of being a toy.
Yeah.
And it turns out both of those are reasons your company can fail.
Yeah.
They could have been the hottest toy of a summer and then the next year fallen off.
Yeah.
And I don't think they ever achieved hottest toy of the summer.
Well, yeah. I mean, the favorite example of that one is the Furby in the robotics domain, right? Furby was like a great robot, but in terms of intelligence, yeah. Oh, it was super successful. It sold, I don't know.
I mean, could it like sense?
Oh, well, that's the thing. So that's what I'm getting to. It was successful as a product because it sold like, I'm going to lie here, but like tens of millions of units, like insane amounts of units.
Yeah.
But when you tore it down, it was actually a very simple robot. Like it had few motors, a few lights, and like a tiny processor that would execute a pre-built thing.
Yep.
And, people would say, oh, Furby would learn to speak. And the trick was Furby would be programmed to speak gibberish from a sound synthesizer chip and would just run a timer and would listen with a microphone. And every time it heard frequencies in the human speech, it would advance the timer. And so the more you talk to it, the less gibberish it would say and the more English it would say. Or French if it was sold in France, or German if it was sold in Germany. And so it was a complete trick. Like, it wouldn't learn anything. It would just run a timer. So it's all this sort of stuff.
I think we're losing the thread a little.
Sorry.
I mean, we haven't even gotten to talk about long Furbies, which are the best internet sensation that apparently you've never seen.
Nope.
They're very creepy. Basically Furby snakes.
Oh, God.
Yeah, they're coming for you. But kind of going back to this and wrapping it up. If there was a small, cheap robot and it had to do something, what do you think it could actually do?
Well, I mean, I think the reason people have chased the delivery robot thing is like, that is the limitation of that is the bleeding edge of what robotics is able to do right now. Sort of navigate indoor/outdoor.
With a lot of teleop.
With a lot of help from humans and sort of roughly get to where it's supposed to go.
Mm-hmm.
And that's like the absolute limit of what we can do. We can't open doors.
Yep.
Can't climb stairs.
Yep.
But we can sort of take a sidewalk. That's That's it so far. Every other machine.
And along those lines, an AMR is basically an indoor delivery bot.
Indoor version of
it's
that.
All delivery bots all the way down.
Yeah, exactly. And a quadrotor is a flying delivery robot.
But in either of those two cases, you're still looking at $10,000-$15,000 a pop.
Yeah.
If you're going to sell a robot for $4,000, what could it do?
Not much more. Like, if I had to,
I always like the idea of like the autonomous luggage.
Oh yeah, there's a few groups that try to do that sort of thing too.
Yeah. I really like the opportunity to look like even more of a tool in the airport, and like having a roll-on suitcase that follows me. And if it's just connected through a digital tether and just really stupid.
You know what killed that market, right?
Huh.
The requirement to pull batteries from smart suitcases.
Well, yeah. I mean, the TSA is
it's not even the TSA.
A great advancer of our liberties and safety.
I think that was actually an international air regulation on like lithium batteries and whatever, like the lithium battery on fire problem.
I will imbibe some of my La Fin du Monde to that. Yeah. So what are we talking about next week, Ilia?
I don't know if we've picked a topic. Have we picked a topic?
Nope.
All right.
We have no idea as of right now, but it's going to be a great one. You better tune in.
We have a few different get-togethers organized this week, so maybe we'll have some fun stories to share next week.
Oh, yeah, I bet, actually.
Yeah.
We have a person coming by the office in a little bit. I even have an event after that I'm supposed to go to. I see a world of a lot of stupid robotics in the next 6 days of my life.
All right, so listen out for the next podcast.
We'll be making fun of people.
Yeah, we might be quietly and not so quietly making fun of people next episode.
Well, thanks you all so much for joining, and we'll see you next time.
See you next time.